All right, now let's talk about our mixtures. All right, finished talking about pure substances which can't be broken down by physical methods. So now we're going to talk about mixtures which can be broken down by physical methods and get into their different types, homogeneous and heterogeneous. So a mixture is something that can be broken down using physical methods, i.e. filtering or just mechanically separating. And then we'll talk about a few other techniques that you can use. But examples of mixtures are going to be, really, you have like a couple of compounds mixed together in the same space, or maybe an element in a compound, something like that. So like sugar, water is a mixture. Right? You've got two pure substances, sugar and water, and you stir them together, and now you have a mixture of sugar and water. All right? You can also think of a mixture as being things like red and orange M&Ms. Right? You can also think really easily how you could separate those. You can just pick out the red and the orange ones. Those are you're not doing a chemical reaction if you're picking out the red ones and eating them and leaving the orange ones behind. So there are two major types or kind of categories of mixtures. Right? There are homogeneous mixtures. Right? That prefix homo means same. All right? So homogeneous mixtures look the same throughout. You can't see the separation of the different components. All right? So like salt water. If you drink salt water, you can taste that the salt is there, but you don't see it. All right? Or syrup is water and then a bunch of dissolved chemicals that give it the brown color. All right? Air around you, you can't see the oxygen part compared to the carbon dioxide part compared to the nitrogen part. It all looks the same. All right? So if it's a mixture but you can't see the separate components apart from each other, then it's a homogeneous mixture. Whereas a heterogeneous mixture, your parts are going to be easily visible. All right, they're distributed unevenly. So hetero means different. So heterogeneous mixtures look different throughout. You can see the different components. Right? So spaghetti and meatballs. You can see the spaghetti and the meatballs, and you can tell that there's different stuff in there really, really easily. All right, water and oil is a heterogeneous mixture because you form the water layer and the oil layer. So let's do some practicing here. Which of the following is a mixture? All right, sometimes you just gotta go with what you know about things. All right, so we've got our formula for table salt here, which is NaCl, or 1 sodium to 1 chlorine. We've got water, which we know is H2O. Orange soda, which I know is like water and sugar, and it's got bubbles in there, which I can see apart from, like I can see the carbon dioxide bubbles apart from the rest of the water. And then you've got mercury, which is an element off the periodic table. So of those, the one that I couldn't say is a pure substance is going to be your orange soda. So C is your right answer. So which of the following is a mixture? Oxygen, nitrogen, air, or carbon dioxide? All right. So which one of those? I mean, really, if you think about it, 3 of these are the components of the mixture. All right. So air is your mixture here because air is made out of oxygen, nitrogen, all right, and these are elements, and then CO2, carbon dioxide. And then which of the following is a homogeneous mixture? So homo means same, which means you're not going to be able to tell the different parts of what's in there. You're not going to be able to see them as being separate from each other. All right, so which one of these things is going to just look the same throughout? So, for me personally, my initial thought would be, all right, I'm going to narrow out the ones that I know I can definitely see different components of. So like Raisin Bran cereal, you can see the bran and you can see the raisins. That's definitely heterogeneous. All right, and if I'm at the beach and I'm, making a sandcastle and stuff like that, like there's rocks in the sand, there's shells in the sand. So, no, that's another heterogeneous mixture. And then I've got to sit there and think, well, cement kind of looks, but you know what, if you look really, really closely at cement, you can see it's speckled, right? So it's not the same like uniform color throughout, so those speckles mean that you're able to see some of the different components. And then there's also, if you think about it like ink, right? I know this isn't actually ink that I'm drawing on here, but that's what it would like if I was using a marker, right? Ink is a homogeneous mixture. It looks the same throughout as I write it. My blue ink stays blue and the same blue the whole time I'm writing. So, some things to know in regards to separating mixtures. All right, so mixtures are things that can be separated by physical methods. These are some examples of physical methods that you need to be familiar with. All right, one that I'm sure you have done if you've ever had coffee, if you've ever had made pasta, all right, used a strainer for something, you've done filtration. All right, so filtration most commonly is used for separating liquids from solid pieces, or you can, based on the filter, you can get smaller pieces to go through and big pieces to get left behind. So that's filtration. Chromatography is in the Unit 1 lab, which we are actually going to focus in on the Unit 2 lab in relation to this unit soon. But if you want to give it a shot, you'll have the materials, you can still run it if you want to. But chromatography separates substances by their densities. Centrifuging, if you've ever seen like a TV show with a science lab and they have a thing that spins like blood samples really, really quickly. So centrifuging is another way to separate things by their densities. Things with bigger densities will get sucked down to the bottom, and stuff with lighter densities will stay on top. And then distillation is a really, really helpful separating mixture. And it plays into the fact that liquids are going to have boiling points that are going to be different than, say, any of the solids that might be dissolved in the liquid, or even if you have a couple of liquids mixed together, they'll probably have different boiling points from each other. So what you can do is boil one of them, the one that has the lower boiling point, off, and then get the other one with the higher boiling point that won't evaporate at the same time. You can get that one left behind. All right, so this distillation just in general is separating liquids via different boiling points. Sometimes you have, two liquids or something that have really, really close boiling points, and then you have to use a special process called fractional distillation, which it just has a different apparatus that you use that makes it easier to separate things with similar boiling points. So, which method would be best for removing salt from seawater? All right, filtration with filter paper, gas chromatography, distilling, or freezing. So, pretty sure you guys can narrow down gas chromatography because we're not dealing with a gas. That would make no sense. All right. You freeze it, the salt's still gonna be in there. So now we gotta sit there and separate these two, filtration with filter paper and distillation. So here is, you gotta go with which method is for sure gonna work, all right? Because filter paper, the salt, it's tiny. So it's probably gonna still get through the filter paper. It's not gonna be small enough holes to actually pull the salt, the molecules of salt, out of the water. Whereas distillation, you can boil off the water and then leave the solid salt behind. So distillation's the right answer there.